All right, I would like you to first start by pausing this video and trying this warm up where I want you to take this piecewise function that is drawn for us and I want you to actually write that function. All right, so hopefully you paused the video and you tried it yourself. This is what the answer should have been. So we have three different functions that are happening here. And so notice that on the far left, this right here is part of a cubic function. So that is why my answer for the first part needs to be raised to the third power. Notice that the middle of that cubic function, which is located it's located right here at the ordered pair -4, 0. It normally starts at the middle being at 0, 0. So that indicates to us that we had a shift to the left. Notice though, when you write it, it has to be inside the parentheses and you're writing it as the opposite side. So that's why it's x plus 4 quantity squared. When we start looking at what the restrictions are for the domain, notice that the left side has an arrow pointing down, which means that everything on the left for x will be a part of that function because it's going to keep heading down. As we move to the right, notice that it stops at x being -3, but it's an open circle. So that means that I do not include it. And so then that is why we had the rest of this being that x had to be less than -3. If I look at the middle function, I see part of a line. It just doesn't have arrows. So that tells us that we're going to start at a point and we're going to end at a point. Notice that the slope is just going up by ones. So that's why we don't have a number connected to x. Your slope is 1. And notice that it's going through the origin 0, 0, which means that you are dealing with a y-intercept of 0. So that's why it's just the line x. Notice that on the far left, there is a closed circle, and that closed circle for x is at -3. So that's why I want to include it. As I move to the right, it stops at +3, but it's an open circle, so I do not want to include it. So that's why my domain restriction goes from -3 being less than or equal to x, which is less than 3. The last function in this piecewise function looks like part of a U. So that means that we are dealing with a quadratic, a degree 2. Notice that the U looks like it is turning here at the point of 4, 0. Normally in a basic quadratic, that turning point is at 0, 0. So that is indicating that we are shifting over to the right. And so because we are over to the right, it's affecting the x. So it's inside the parentheses with the x, but notice that it is a subtraction sign because we're going in the opposite direction. If you look at, it's on the far left, it starts at 3 for x, and it is a closed circle, so I want to include it. As I'm going to the right, I see that there is an arrow pointing up. So that means that every single x to the right is going to be a part of this graph. So that's why my restriction is that x has to be greater than or equal to 3. So hopefully that made sense as I was explaining it, and hopefully you were getting there. Notice that we had to have f of x equals, and then we had these three different pieces. All right, so we are going to continue with lesson 3.5, which is algebra and the composition of functions. We're going to continue to do our different operations. So we're going to look at an example. We're going to add, subtract, multiply, and divide two functions, and then determine the domain of each. Okay, so this is the example we're going to look at. We know that f of x is representing x squared plus 2. G of x is representing the square root of x minus 5. So I want us to find the sum, the difference, the product, and the quotient, and then we are going to determine the domain for each. Now, because it's saying f and g, we're going to start with f, and we're going to end with g when we're doing these operations. So that means that I'm going to start by doing f plus g of x. So that means that I want to take the function f of x, which is x squared plus 2, and I want to add the g of x function, which is the square root of x minus 5. Notice that with addition, in order to finish, we need to combine any like terms. Well, x squared is the only term in that regard. 2 is the only number, and then you have a square root. So this is as far as you can simplify for this sum. So that is that part of the answer. Next, we want to talk about the domain. Domain means that you're looking at each individual term. So if I just look at the f of x function, because f of x is a quadratic, notice that there is no square root in this function. There is no fraction with a variable in the denominator. So that means that the overall just f of x function is not going to have any restrictions at all. If I look at the g of x function, we are dealing with a square root. So right off the bat, that means that you will have a restriction. When you are dealing with a square root, you never want to have a negative number under it because that results in imaginary numbers. So that means to determine the domain for this g of x function, you take what is under the radical and you set it greater than or equal to 0. So notice that means I just have to add the 5, and our restrictions for the g of x function is that x has to be greater than or equal to 5. If I look at the overall sum that we just created, it results in the same idea where the only restriction we're going to have is what is under that radical, which we already talked about with the g of x function. So that means that x being greater than or equal to 5 has to be the domain for this sum. So when you're writing that domain, remember that means that if x has to be greater than or equal to 5, x is the element of, I want to start with 5 and it is included, so it has a bracket, but it can be anything that is greater. So there is my domain for that sum. If I want to do the difference, if I'm thinking of f minus g of x, we'll start with the f of x function, which is the x squared plus 2, minus, now I want to do the g of x function. Well, the nice thing is that g of x is only one single term. It is this entire square root. Had there been more than one term, so a different term with that square root, we would have had to put that in parentheses, distribute the negative, and then start combining like terms. But in this case, we didn't need the parentheses because there was only one thing that we were subtracting. Similar to the sum, there's nothing that I can combine like terms-wise, so this would be the difference. If I look, same idea as far as the f of x function is not going to have any restrictions for the domain. The g of x function will. It has to be that x is greater than or equal to 5. If I look at now this difference that we just created, it's going to still contain that radical. So once again, your domain is going to be just what it was when we did the sum. It's going to be affected by that radical. So we have to start with 5. It can be included, but then it can be anything that's bigger or greater. Now if I move over to the product, if I'm thinking of f times g of x, that means that I'm taking my f of x function, which is x squared plus 2, and I'm multiplying it by the g of x function, which is the square root of x minus 5. I'm going to go ahead and I'm going to distribute this out. That x squared is getting multiplied by this radical of x minus 5, plus, then I'm going to distribute the 2 to that square root as well. There's nothing really that I can do any farther besides just distributing the x squared and the 2 to that radical. So this would be the product. Once again, my original functions, the f of x doesn't have any restrictions for the domain. The g of x does. It has to be greater than or equal to 5. If I look at the product, the only thing that I see is once again that radical, that x is going to have to be greater than or equal to 5. So just like the other two, the domain is going to be 5 included up to positive infinity. The last thing that I want us to do is the quotient. So it's going to be f divided by g. Because f is in the numerator, we're going to start with that x squared plus 2 on the top of our division. The square root of x minus 5 is going to go underneath it. There's nothing that I can do to simplify this any further, so this would be the quotient of those two functions. Now, the f of x function doesn't have any restrictions. The g of x function does. It has to be greater than or equal to 5. This time, though, our domain is going to be slightly different. And the reason for that is because that square root, as we can see, is actually in the denominator of a fraction. And remember, in a denominator, you never want that to equal 0, because if you divide by 0, you have something that is undefined. So actually this time, we have to take that x minus 5, and I can only set it greater than 0. It cannot be equal to, because I don't want to divide by 0. So this time, x is greater than 5. So my domain is going to not include 5. I have to start with 5 with a parenthesis, and then it can be going up to positive infinity. So that was the one slight difference in this particular problem. Just always look to see what are you dividing by. You can never have that division of 0. So I had to exclude 0 from that final domain. Hopefully each of those examples makes sense. If you do have any questions, make sure that you reach out to me over the weekend. Otherwise, your homework is going to be what I talked about the day before. It is on page 309, numbers 5 through 41, odd. Make sure that is ready to go for us to check on Monday.